expiratory reserve. Now to do that expiratory reserve, I really need to pull down on the ribs, right? They really get pulled down. That's the internal intercostal muscles. They sit like this and they pull the ribs down. When the ribs get pulled down, they get pulled in, and the volume of the thorax decreases. Right? The other thing I do is I contract the abdominal muscles. They squeeze the abdominal organs in, and they get pushed up against the diaphragm. So pushing the diaphragm up. So I push the diaphragm up, I pull the chest down, the volume of the thorax decreases, the pressure in the thorax goes way up, and air moves out to equilibrate with atmosphere. Is that okay? So those would involve expiratory muscles, right? We would have to send signals to expiratory muscles to forcefully do that. But at rest, we don't even use those muscles at rest. I don't know. You can read back through the anatomy. That doesn't really matter so much there, the conducting. But this is where we're really trying to get that air. We're really trying to get that air down in these microscopic structures, alveoli. And look at how this sits, right? We have all of these conducting passageways down through here, and then they terminate in these alveolar sacs, and these are the individual alveoli, singular the alveolus sitting there. And notice how that they're totally surrounded by capillaries, pulmonary capillaries. That makes sense, right? Because we need to do gas exchange between air in the alveolus and blood in pulmonary capillaries. Now, each lung is surrounded by a serous membrane, just like a lot of organs are in the body. And this serous membrane is called the pleural membrane. Okay? And there is a visceral pleura here. It's a double membrane, just like everything. A visceral pleura right here that is attached to, if you will, the organ, the lung. There's a parietal pleura along the outside. And this parietal pleura along the outside is really attached to the rib cage, right, on the internal surface of the rib cage. So you'll notice what we've got here is we have a space in between the two pleura, right? And we have a space inside the lung, and then we have the atmospheric pressure or space out there. Now we're going to see in a minute that these are all really important areas. So let's say if we were outside the body out here, okay, this is the atmosphere, and there's an atmospheric pressure out here. Right? Inside the lung, in here, there's a pressure. And we're going to call this the, what do we call it? The intrapleural, oh, no I didn't. Intrapulmonary pressure there. Okay, that's the pressure inside the lung. And then we're going to see also that there is a pressure inside this potential space between the pleura. You okay with that? And this one we're going to call the pressure, this one will be intra, for inside of the pleura. But anyhow, intrapleural. Right? So we have three pressures now we got to worry about. We have atmospheric pressure. We have intrapulmonary pressure. And we have intrapleural pressure. Okay? You guys okay with that? Because those are three spaces, right? Now normally there's what inside here? Normally there's fluid in here. And the whole purpose of this fluid-filled space is to prevent friction, right? Every time you're inhaling and exhaling, the lung tissue is moving. We wouldn't want it rubbing against other tissues in the body because that would be abrasive and damaging and things like that. So again, we separate, we put a water barrier in between them to reduce the friction between the lung tissue and the body wall. Okay, and that's the whole purpose of the pleural membrane, is to do that. Now we're going to see here in a minute that this intrapleural pressure right here, this is vital in preventing lung collapse. We'll see why in a minute. But that really helps us prevent the lungs from collapsing. And that's really important because we've established that if your lung collapses, it's very difficult to breathe. Let's see what else we got here.